Hi everyone, my name is Jeremy Paparozzi and I'm a third year medical student currently studying at Nova Southeastern University in Fort Lauderdale, Florida. I am excited to present the systematic review that I worked on with a few of my peers, highlighted in yellow. The title of the poster is Nutraceutical Enhancement of Paraoxonase-1 Activity and its Implications in Rheumatoid Arthritis Management. So the idea for this project initially spawned about a year ago when I was working on a different paper with a rheumatologist associated with my university. We were writing about rheumatoid arthritis, and while I did my initial literature search for the topic, I found an interesting article that discussed what they referred to as the lipid paradox in rheumatoid arthritis. What they meant by this was they were finding that elevated levels of HDL-C cholesterol and lower levels of LDL-C cholesterol actually were associated with increased rates of adverse cardiac events in the rheumatoid arthritis population, which is paradoxical as compared to the general association of these particles and their levels in the general population. So I looked into the potential mechanisms for why this could happen, and that's when I stumbled upon the paraoxonase-1 enzyme. So the paraoxonase-1 enzyme is a key enzyme nestled within the hydrophobic lipid domain of the HDL-C outer membrane. Function of this enzyme is integral to the HDL-C particles' two primary cardioprotective duties. Those are antioxidation and cholesterol efflux. The paraoxonase enzyme exhibits antioxidant properties by hydrolyzing oxidized lipids, thereby preventing the formation of highly atherogenic particles like oxidized LDL. The enzyme also enhances cholesterol efflux from foamy macrophages and arterial walls, reversing plaque formation. So basically, the paraoxonase-1 enzyme is nestled on the outer membrane of the HDL-C particle, and this is the workhorse. It's the antioxidant workhorse of the HDL-C particle. It's very cardioprotective. So what we did here was we conducted a systematic search on PubMed for studies published between 2010 and 2024 using keywords related to nutraceuticals, paraoxonase-1, and HDL particles. We filtered for randomized control trials written in the English language, and this returned 170 articles that ended up being screened. Duplicates were removed, of course. Inclusion and exclusion criteria were applied, and we ended up with 23 eligible studies. These 23 eligible studies were all randomized control trials that discussed the supplementation of specific nutraceutical compounds listed in the first column of my results table that had proven efficacy in elevating serum concentrations or just activity of PON1 in human subjects. So, of these papers, of the 23 papers that made the final cut, 10 of them talked about anthocyanin. Anthocyanin is a polyphenolic compound. It is a water-soluble pigment that gives a lot of fruits their blue, purple, or red hues. So it's a very substantial. It can be found in substantial concentrations, I should say, in blueberries, blackberries, raspberries, red grapes, and pomegranates. And I want to specifically highlight anthocyanin as compared to all of the other nutraceutical substances in this table, because all of the nutraceutical substances, as you can see in the key results column, all of these had proven efficacy in increasing PON1 activity in human subjects. However, anthocyanin to me is one of the most interesting because, as you read in the key results, anthocyanin supplementation at 320 milligrams significantly increases activity of HDL and the PON1 complex. Now, the reason this is so interesting to me is because since there were 10 trials, I was able to figure out which dose of anthocyanin proved most efficacious in activating HDL and PON1, and this 320 milligram dose seems to be the best. The reason that's so interesting is because in 320 milligrams of anthocyanin, you could find in about a cup or a cup and a half of blueberries. Um, all of the other nutraceutical substances, we would need to develop supplements to obtain the dose that has been studied in increasing PON1. But anthocyanin, you could just recommend to patients living with rheumatoid arthritis to eat 1 cup or 1.5 cups of blueberries every morning with yogurt or something, and theoretically, that should at least help reactivate the PON1 molecule and confer cardioprotection. Now, the issue with this is that only one of the 23 clinical trials that we found actually tested the nutraceutical substances in rheumatoid arthritis patients. So theoretically, there is potential for use of nutraceutical supplements in helping cardioprotection in rheumatoid arthritis patients, but much more research needs to be done on these patients. So